Hey guys, Mr. T here. This is a video on geometry, or geometry revision, to be honest, because this should all be revision from previous years. Get your memories up and running, because some of these facts and little figures here you'll be using for problems to come. So geometry is the study of shape, size, and position of figures, figures being just like drawings, diagrams. It's important to understand some of these general geometry rules and terms that we're going to deal with, so you can handle the problems that we're going to solve. So the first term is a point, which is a location in space. We're only dealing with 2D space for now, but you'll be dealing with 3D eventually. A point is indicated with a dot and should always be labelled, generally with a capital letter. For example, here, dot, that's the point there, and its label is capital P. So this represents a point, and we've labelled it P. A line is an infinite set of points passing through two other points. Lines continue forever in both directions, so remember that, indicated by arrowheads on both ends. Usually defined by 2 points lying on the line in brackets. So I've said a line is an infinite set of points. This blue line here with the arrowheads is a line. It goes on infinitely. That's why the arrowheads are there. And it's made up of points all the way along, an infinite amount. Okay, and because it goes through the points A and B, it's defined by those 2 points. So in this case, because this blue line goes through points A and B, we define it using these curved brackets, and this is a line AB because it passes through the points A and B. Now, the idea of a line segment is basically a small part of an infinite line. So we're not talking a line that goes on forever. Here we're only talking about part of it. It definitely stops and it definitely starts. The endpoints of the line segment are used to define the line segment, but this time in square brackets. So in this case, here we have a line segment. See how it doesn't have arrows, so it must be a line segment, and it starts and stops at the points X and Y. We don't have a direction here. It can be from X to Y, it can be from Y to X. We're defining it as the line segment XY in square brackets, because it goes between the points X and Y. The next idea is the idea of an angle. An angle is the space formed between two lines meeting at a point. So here we have, what will we call these? There's no arrows on either end, so it must be a line segment. We have a line segment BA and a line segment A to C. They meet at the point A. This space here between, marked in blue, is called an angle. So the angle BAC, B to A to C, which we can label like this, little sort of beak here is like a symbol for angle, BAC, is formed at the point A, where the line segment BA and the line segment CA meet each other. So the angle is that space between those lines, formed where they meet. The idea of parallelism, two lines are parallel when they never meet. So there's not an angle between them. They can't form an angle anyway because they never meet. But if they were on top of each other, there'd be an angle of 0 between them. Because of this, they're all going to go infinitely and never touch. So parallel lines are indicated with arrowheads on the line, not on the ends. So the end arrowheads indicate they're going forever. The arrowhead on the line indicates that they're parallel. So the line AB and XY, notice how I've put curled brackets there, because it's a line, not a line segment. On both of these are parallel lines. They're never going to meet, and they're not going to get further apart either. So just remember, with parallel lines, yes, they're never going to meet, but they're also never going to be further apart too. Perpendicular is the next term you need to be aware of. Two lines are perpendicular if they meet and form an angle of 90. So here we've got line segments meeting, so they're going to form an angle, but perpendicular specifically relates to when the angle is 90 degrees. So line segment AB and BC, they meet at point B, and the angle formed there is 90 degrees, so they are perpendicular. It's a special case of an angle. The next thing we have to think about is parallel line properties. So some problems we're going to face will make use of special properties of when a line crosses two other lines that are parallel to each other. So hopefully this is a revision. If not, this is a refresher. So the idea of corresponding angles. Angles in a corresponding position when one line crosses two other lines which are parallel are equal. So here we have two parallel lines. We have a third line crossing them both. You get an angle formed here and an angle formed there. They're in corresponding positions. You can see that this is sort of going down to the right, and this is the other angle in the corresponding position because the line goes down and to the right. They're in corresponding positions, therefore angle A is equal to angle B. As an aside to that, just remember there's other corresponding positions too. Here you've got the angle that's formed between this line going down and to the left. There's a corresponding angle down here as well, down and to the left. So we'll call that Y. X would also be equal to Y. So look for corresponding positions there. We're in the same sort of the shape there. So that's the first one, corresponding angles. Alternate angles. So when angles in alternate positions, when a line crosses two parallel lines, they're equal as well. So the previous one, corresponding positions meant the angles were equal. Here, alternate positions, so you have this angle here formed by the parallel line and the line crossing going down, and this angle here, B, from the line going down and then going across, they're alternate. They're across from each other. They're going to be equal as well. So angle A is equal to angle B because of the alternate angles property. But just like above, there's other alternate angles here. Here we've got one angle. What's alternate to it is on this side as well, because you have across and up, and here you have up and across. They alternate with each other, so X is also equal to Y there because they're in alternate positions too. The last one for this video is the idea of cointerior angles. Angles on the same side, which is termed cointerior, of a line that crosses two parallel lines add up to 180 degrees, and any angles that add up to 180 degrees, they're called supplementary to each other. So here we have two parallel lines and a line crossing. These two angles here are on the same side of that crossing line. They're sort of inside this block here. They're called cointerior. Why? Because they're on the same side of the crossing line, and according to this rule, those two angles are going to add up to 180 degrees. So if you know one, you can work out the other by subtracting it from 180 degrees. Again, there's another aside to that. These angles are also cointerior. They're on the same side of the crossing line, and so X plus Y are going to equal 180 degrees. And just for interest's sake, if you look at the rules above, you'll notice that B is alternate to X, and alternate angles are equal. And A is alternate to Y, and alternate angles are equal. So this rule, this cointerior angle rule, actually comes about because of the previous rules. And we can conclude that A plus B is equal to 180 degrees because if you look at this here, this parallel line, we know that this angle is A, we know that this angle is B. We just proved that they both add up to this straight purple line here, and a straight line has an angle of 180 degrees. So that's another sort of proving of this rule. Yeah, so hopefully this helps you out. Hopefully it's a little bit of a revision for you, and I will see you in the next video.